So this is lesson 2.1.2, and you as a group, in groups in your class, would probably go through and figure all the answers out to these equations and questions, because there's quite a few. This is Parabola Lab Part 1 is 2-11, and that's what I'm going to start with. They have asked us, and you see quite a few things I've already done here off to the side in Desmos, but I will talk about them as I go. So I have y equals x minus 2 times x minus 2, and you can see that that is graphed here. There's a few things I want you to see. This particular function right here, this particular equation, is the same as the equation above. So I'm just going to go ahead and highlight that so you see it. And notice I graphed it. It's the same color. Let's just change the color for a moment so that you guys can get an idea that it really is the same graph. Okay. All right. And then what you see down here, I have written this parabola has a minimum and the vertex, and it is 2, 0. The y value always points to the minimum or the maximum on a quadratic, and the x value always is your line of symmetry. So in this particular thing, we're talking about what is this line of symmetry? Symmetry means it has to basically cut it in half, so they are the same if we reflected them. And so I'm going to go ahead and click on this x equals 2 because that's our line of symmetry, and you'll see where it's drawn it there, okay? We also have a vertex, which is a minimum as well, so I'm going to go ahead and say that. And it's at 2, 0. So you'll see that there's a point plotted at 2, 0, and the vertex is minimum, okay? And that ends that part of it. But now they want you to have equations that are going to have the same vertex but look different. The bottom line you need to realize is that I need to have two sets of equations, like two factors. These are factors, x minus 2 and x minus 2. So I come up with two more sets of parentheses that are identical, that if I plug 2 in, I'm going to get 0. And so let's just start with a simple one so you can see what I'm talking about. I'm going to say y equals, but then I'm going to double the values on the inside. So instead of a single x, I'm going to say 2x. And instead of negative 2, I'm going to say minus 4. Okay? Close parentheses. Oops, that's an open parenthesis. Then I'm going to put another one just like it. All right, you see that? I have 2 here that are now, you've got the equation from the beginning, and then you've got the new equation with the y equals 2x minus 4 times 2x minus 4. Let's throw in a couple more. Let's just triple the original. So let's do y equals 3x minus 6 times 3x minus 6. Look at that. You have another equation there, okay? So you're seeing the idea of what I'm talking about. Let's take and look at what would happen if this was, so those are both stretched vertically. Now what would happen if I made it a fraction, okay? Instead, so instead of doubling and tripling, I'm now going to cut them in half. So y equals, and inside I'm going to put 1/2 x minus 1 times 1/2, which you won't typically see fractions doing this, but you still can do it, x minus 1. And look at that. The black here is a vertical compression, so it's like smashing it from the top. So in the middle, let's go back up here and make sure that we have our original in a color that's different. I'm going to go ahead and make it orange because there's no other orange on the graph. Okay, and we'll get rid of this because then the orange will show up. Okay, there is the orange. This is our original. So we had 2 that were vertically stretched. We pushed them together, and then we have a vertical compression here with the fraction. So that helps explain A, B, and C. Now, another thing that wait, what am I saying? A and B. Sorry about that. All right, so now what we're going to do, it also asks us on C to use the graphing calculator. We're using Desmos to find the equations of 2 different parabolas that open downward that have the same vertex. So all I have to do on that is take the original and put a negative in front of it, okay? Because that is going to make it reflect across the x-axis, but point downward and have a maximum, which would be 2, 0 instead of a minimum. So let's go ahead and do that. So just x minus 2 times x minus 2. All right, and if you notice that, It's very similar. It's a reflection across the x-axis of the orange graph, which is our original. And all I did was put a negative in front of it. Now, I'm going to go ahead, I'm going to pick on these three and see if I can go ahead and just put a negative in front of them and have them flip down as well. So we're just going to go ahead and put a negative, and look what happens. It brings that one down. And then let's put a negative in front of this 3x minus 6 times 3x minus 6. Same thing. And then the last one that we came and we did a vertical compression because we used a fraction. Let's put a negative in front of that. And all of those are now downward. And if I want to, I can just go ahead and pick and choose what I put back. But that answers your part of C. Okay, and then D is a little different because it wants us to come up with an equation that is negative 4, 0. So let me get a new graph and we'll go from there. So just one moment. Okay, now it says we're going to use our graphing calculator to find the equation of a parabola that opens downward with a vertex at negative 4, 0. So why don't we first off figure out where that vertex is? So let's just plot that point. And they said negative 4, 0. So there's our point. This is also our vertex. And at this point, we don't know. It does say it wants it to point downward. So that means it's going to be a maximum. Oops, got to be able to spell that right. All right, and I'm going to place that. These are all, I'm also showing you how you can place things. So if I want, I'm going to hit that button, and if I want to place it somewhere, I'm going to go ahead and, because this is a maximum, I want it to be above where our point is, but I also want the point to show as well. Okay, so we've got the point, and that's our vertex and our maximum. All right, now, when I do that, that means I've got to think about what's that equation going to look like. I also pointed out to you earlier that the axis of symmetry is always your x value. So we're going to go ahead and plot the axis of symmetry, the line of symmetry for this particular graph, and that would be x equals negative 4. So I'm going to put x equals negative 4, all right? And I'm just going to let that line be there, okay? Then we have a question about the negative 4, 0. Well, our last graph we did, if we go back and look at it at some point, you can look at it in your notes, it had it at 2, 0, and that was x minus 2. So I'm going to try x plus 4, okay? That's what we're going to do, okay? So I'm going to say y equals x plus 4, and then x plus 4. Okay, so that gives us the right vertex, but there's one thing that's missing. It asked us to open this downward, so I need to put a negative in front of it. There's the graph that they've asked us to graph. And then we also are going to choose another one, another vertex here, and we'll just do this on the same graph. It says on part E, choose a new point on the x-axis and find at least 3 equations of parabolas that touch the x-axis only at that one point. All right, so let's pick a different one. Let's pick on 10 since it's far away. So we're going to do this. We're going to say y equals, and we're going to do x minus 10. I hope you're catching a pattern here, that when it's minus, it's going to the right, and when it's positive, it's going to the left. Let's see here. It's right now, it's still looking linear. All right, so we've done that. So now I'm going to create another equation. So I'm going to double it. It wants 3 other equations. First, let's put a negative in front of it. So y equals a negative x minus 10 times x minus 10. All right. You'll see that. So there's one equation. It wants 2 more. So let's double it. Let's just try that. I'm going to do y equals 2x minus 20 times 2x minus 20. Okay, that gives me 1, and I need 1 more equation, okay? So I'm going to do, what do I want to do? Let's do a compression. Let's go y equals, and we're going to say 1/2 x minus 5 times 1/2 x minus 5. Oops, I did that wrong. Sorry, getting some weird stuff there. minus 5. And so we have a vertical compression. So this takes care of this part. The first few steps take care of part C, or D, I should say. And then this part takes care of part E. And that helps you all with 2-11's Parabola Lab Part 1. Lots of information here. Lots of stuff to look back again at if you want. This is a fun unit for me, but I know it's really tricky, and especially during the pandemic when multiple people didn't get a chance to focus as much on quadratics. So you're learning a lot of new things too. So here we go, and we'll move on to the next problem. Okay, so you're going to notice on this lesson that I've skipped over 2-12 because that's really predominantly something that you would do in your groups at school. And I'm pretty much covering all of the concepts that 2-12 would have by doing the other problems for the lesson. So right now we're on 2-13, and right on it says graph y equals x squared, and be sure to label any important points. So what we're going to do is we're going to start by labeling the point. This is the parent function, by the way, for the quadratic. So I'm going to come up here and I'm going to put a quote mark in here, so I can type some things that we would want to know about this particular graph. So this is the parent function for a quadratic. It has a vertex at the point of origin, which is 0, 0. And it has a minimum because it is pointing upwards. If I come down here and I say y equals a negative x squared, then you would have it pointing downward, but we're not worried about that at this second, okay? All right, so let's go over here and let's just plot that vertex point so we have it. So I'm going to say 0, 0, and we're going to label that as our vertex. And I've actually shown you how to do this before. I like where that's placed, so I'm not going to worry about it right now. I've also talked in the previous problem about what the axis of symmetry here is. Axis of symmetry here, sorry, as I stutter. Axis of symmetry here is just x equals 0, and it's the y-axis. So, oops. All right. And so you see it going through the y-axis there. All right. So that covers the base of what we're starting to do. Part A on this one says, find an equation that has a parabola stretch vertically, which means it would be skinnier. It would be on the inside of the parent function that we have right now. So I'm just going to pick a random number, and I'm going to put y equals 4x squared. Okay, notice here, I'm going to change that color because I don't want red on red. I want it to be, okay, let's do blue. All right, so that's a vertical stretch is what I should say, not compression. And let's look at what the table of values does for that. So let's just take a look because I'm curious too. All right, let's take a look. All right, so we've got our values here of -2, 16, -1. You can see how it's a vertical stretch, but let's put a table in for the y equals x squared as well, so you can see that one. All right, so you've got, these are the points, -2, 4. So look at the points and how it stretches, it's vertically stretching. So if I pull this down, you can see how it's a vertical stretch, all right? So that helps with that. So let's go back to the equation if we can. Okay, so now that we have the equations back, that gave you an idea of what happens with the tables. Okay, and so now it wants you to do one where you compress it vertically. Well, that takes a fraction. So let's just come here and do y equals 1/2 x squared. All right. There's a vertical compression because here's our original and it compresses to go out wider, okay? Whereas our vertical stretch goes in and pulls in and is going vertically skinnier, I guess, for a better, lack of a better term in the top of my head right now. All right, now we've got all of our information for A and B, and now what it wants to do is say, hey, how do you take that original equation and point it downward? Well, the new parabola is going to be the same size as the original. It's just we're going to put a negative in front of it. So let's just do another equation. Y equals negative x squared. And notice how it points downward now, but it's a reflection of our red graph here, which is y equals x squared. Reflects over the x-axis. Okay, and that is part C. Part D, we're going to get into where we're talking about translating the parent function. So now it's open downward, and we want to make sure, now we want to move down the equation that we started with so that it has a vertex of -5. So let's just go from, let's mute these other equations for right now because we've shown those. Okay. And now let's just translate this one down. All right, and when we do that, basically we're just shifting it down 5. So we say y equals x squared minus 5. Notice that this is the same graph moved down 5 units. If I was to take the -5 off, it definitely is coinciding with our original graph with y equals x squared. But let's go ahead and leave it at -5. You'll notice it has a minimum now at 0, -5. That's its vertex. And then you notice that we don't have any parentheses. It's not like x minus 5 squared. It looks a little different than the one we did before. Because if it was x minus 5, let's try that. So y equals, and let's put parentheses, x minus 5 squared. Look what happens. That is a horizontal translation, this red graph. That's horizontal. This was a vertical translation. So those are things you're going to start figuring out as you're working more and more with these. Okay, so let's go back to this. And let's see, so now what it wants, we've got the vertex, that's the part D where we moved 5 units down. So let's look at part E. With part E, we kind of started talking about it when I changed that vertical translation to a horizontal. But this one is asking us to move 3 units to the right. And if you look back at problem 2-11, you will see that that x minus 2 was one of those. So let's go ahead and we're going to change our equation here to y equals, and remember you have to think opposite of what you're putting in there because we need it to evaluate to a 0. So if I'm going to put this in here, it's going to be x minus 3 because I'm trying to go to the right. But I also have to remember to square it. All right, see that? That is a translation of 3 units to the right, okay? And that helps with that particular problem. That's part E. So for part F, what I'm going to go ahead and do is I'm going to mute this vertical equation right now. And we're going to talk a little bit more about, this is a horizontal translation. But part F wants you to have that go 3 units to the left and stretch vertically like we did in part A. So when we did this equation right here where we stretched vertically at 4x squared, it wants us to do something similar to that, but it wants us to move it 3 to the left. So what I'm going to go ahead and do is, instead of x minus 3, we're going to start with y equals x plus 3. So let's do that translation first. I'm sorry if you hear a dog snoring, it's because my dog is snoring and he's laying right next to me on the floor. All right, so now we have moved it. So I'm going to mute this one as well because we just want to see, just a second here, we just want to see this translation to the left. And so we have a vertex at -3, 0, which is good. But now it wants us to vertically stretch it. So all I'm going to do is put a 4 in front of this using our example from above and see what happens. And that vertically stretched it. So let's come up here, change this to a plus so you can see the difference. All right. And then I'm going to let that equation show. So this would have, the blue would have been a horizontal translation to the left without a vertical stretch. But then once I put the 4 in front of it, it is skinnier and it shows the vertical stretch. So hopefully that all helps. That's 2-13, and I'm going to move on before my dog snores so loudly you're all going crazy. Yep, I just can't let him leave my side, so here we go. Okay, this is problem 2-14. I'm not going to be doing 2-15 because that is the kind of problem where there's all kinds of correct answers. And so I'm just not going to cover that. And similar to 2-13, I am covering all of the concepts that need to be covered with these 3 problems that I have chosen to do. So let's just go ahead and start on this one. This is the last one. It won't take long, but it's taking everything that we've talked about with regard to translations and stretching and compressing and negatives and all of that, and it's rolling it into one equation. So this one says, find a way to change the equation to make the y equals x squared parabola vertically compressed. Open down, move 6 units up, and move 2 units to the left. To the left, to the left. Sorry, I just, every time I say those words, I want to sing that song, even though I don't know the rest of the words. Where is the vertex of your new parabola? Okay, so we've got our parent function right here. We have this y equals x squared. So what I'm going to do is I'm going to start with a vertical compression. A vertical compression means that my coefficient has to be less than 1. It has to be in fraction form. So let's just do y equals, I've already done a 1/2 x earlier, so let's do 1/4 x squared. Okay, you see the vertical compression here. It's like somebody sitting on top of the black graph and kind of squashing it down. That's what happens when you use a fraction. So then it says that we need it to open downward. Well, the only thing I need to do to open it downward is put a negative in front of it, okay? And I don't like, I did that last time too, so let's do this. All right, there we go. I like that, I prefer it. Okay, then it says move 6 units up. Well, we don't have any parentheses, so we don't have a horizontal translation yet, and the vertical translations always happen outside of the parentheses. So we're gonna go and just put it add 6, all right? You see where it's happening, okay? It moved up 6. So now you are at 0, 6 for your vertex, and it's a maximum. But then it also says we need to move 2 units to the left. I promise I won't sing this time. And you need to think opposite. If I'm going in a negative direction, my parentheses have to say plus. So I'm going to come here and I'm going to put parentheses. And I'm going to put x plus, they want 2 units to the left, 2. You see the craziness happening to the graph while I'm still deciding what to do. And then I've got x plus 2 squared, and I've got it up 6. So let's take a look at what our vertex is. I'm going to go ahead and mute the parent function. But anyway, this goes from the parent function with all the information that we just did in this quadratic. It now has this information as the answer. So let me go ahead and mute the parent function for just a second. Okay. And we're going to talk about what is our axis of symmetry here. It didn't ask us to do this in the problem, but I want you to get used to it. So our vertex is at -2, 6. All right, so we're going to plot that point. That's our vertex. That was a question on it. It is the vertex, and it represents a maximum. So that's the vertex, all right? This is a maximum because everything else opens downward. Our axis of symmetry is what's going to cut the graph in half. And so that's the x value of the vertex, which is -2. So we're just going to say x equals -2. All right, you have your vertex there. And then the minimum or the maximum in this case would be at 6. So you use the y value for your maximum or your minimum, and then x value as your axis of symmetry. So you have, this is 2-14, and hopefully it helped, and you can try it with many other equations in different directions and play with it. So, and that ends all of the problems for lesson 2.1.2. Remember, if you have any questions, put them in the comments down below. Give me a thumbs up if you like this video and want to see more, and also subscribe, and then you'll get notifications of all the new videos that are coming out. But I hope you have a great day, and we'll see you on the next video, which will be the review and preview video. Thanks so much.